Pilot 4, Stamping Die Repair via Laser DED.
Coskunöz produce mold dies about 50 years. Our experiences for specific technologies, not only mold production, especially stamping too. At our R&D center, we have lots of repairing methods for die manufacturing, mold manufacturing, because after stamping, periodically molds coming us to maintain, and the maintain quality is a big factor for customer demands.
What is broken today and how stamping dies are repaired or replaced in the automotive supply chain? What is the real pain commercially, operationally, or in terms of sustainability?
I can demonstrate this by comparing the direct energy deposition method with conventional welding technologies, which we uses for repair molds. DED and laser repair produce a more homogeneous and stable microstructure. In conventional welding, sometimes operator-related variations make service life unpredictable and digital modeling difficulties. On the other hand, carbide clustering and microstructural homogeneities, not homogeneities, heterogeneities may also occur. High deposition and wide high heat input at repairing area, repairing zone, increase CNC times and make polishing more harder.
CKM projects over 1,100 repaired stamping dies in the 5 years after diameter. What needs to happen during the project for that number to be realistic?
Periodic maintenance and repair of our active stamping molds, which are at our customer for OEMs and Tier 1s, of course, performed in Coskunöz kalıp makine in-house. Our projects as last 6 to 10 years about, and the molds require regular maintenance and undergo about 15 or 20 revisions on average. And considering potential project nominations, if we look our potential project nominations, existing molds in operation at customer side, and this number appears very realistic.
Automotive customers are among the most demanding in terms of quality standards and cycle times. What will it take to convince them that a Laser DED repaired mold is as reliable as a new one?
Although a mold repaired by DED shows some microstructural differences from the base material, it must perform not equivalently in service. It must be equivalently in service. So the metallurgical and mechanical tests conducted within the project will verify the equivalence between the repaired zone and the base material. Demonstrating and documenting these equivalences is one of the project's key deliverables.
The environmental case is also significant. Every repaired mold is one that avoids landfill and does not require new raw material extraction. Is this argument already relevant to your customers, or is it still primarily a cost conversation?
The environmental argument is increasingly valid, but in the automotive industry, it is not sufficient alone. Cost and production community continuity drive decisions, while sustainability acts as an accelerator and formal enabler.
What would it mean for CKM and for the sector if this approach became a standard repair method in the European automotive tooling supply chain?
I have a basic answer for this question. This method will transform repair, production, design and maintenance. So mold would become renewable strategic assets, not consumables.